Ever wondered how Google Maps or any other navigation app instantly finds the absolute fastest way to get you to your destination? Well, it's all thanks to one clever algorithm, which is the Dijkstra's algorithm. To a computer, roads are edges, and the cost to travel is time or distance. The algorithm's only job is to minimize the total cost. That means find the Dijkstra's route possible. This is a greedy algorithm, and it ignores parts that looks complicated. It always picks the most optimal choice at every single step, which is why it's so fast. Okay, so here's an illustration showing the graph from A to H. The final destination we're aiming for is D, and we're in a car navigating toward that final destination. We start at vertex A with initial cost of 0. We look at all outgoing paths. A to B is 8, A to F is 2, and A to G is 1. The face marker, which is us, instantly moves along the path with the lowest cost. We are greedy, obviously, and we confirm G as the shortest current path. We travel to G, which connects to C with a cost of 3. Total cost to C is 1 plus 3, and that gives 4. That becomes our new shortest path. We thus move to C. C connects to E with a cost of 1, and finally to D with a cost of 2. The total cost to D is 7. We have just cut down the cost of travel by following the shortest path, and that's less work for the computer later. So now, even though the path ABE looks direct, its total cost is 11. The algorithm thus has found the shortest possible route through G, C, and E, and finally reaching D with a total cost of 7, which is shorter than the other path, ABED. Following the same graph analysis, we can also see this in Dart code. Here's a simple dungeon chase game that uses the algorithm which I created. But this game revealed a critical concept, time complexity. For a simple game grid, the algorithm is fast enough. However, on a real-world map with billions of nodes, simple coding would lead to quadratic complexity, which would grow rapidly and make it far too slow for apps like Google Maps to calculate these distances. So what's the solution? The solution is using a priority queue, which changes the maps to efficient logarithmic time. That small change is why navigation is instant, even with billions of roads. That work is offloaded to a specialized server having Dijkstra algorithm or its variants, leading to improved performance in applications. You can also see this in a full implementation in Dart DSA or Data Structure and Algorithm book by Jonathan Sunday. The calculation itself runs within the shortest path method, which iteratively updates this pairs via priority queue. If you ever have a situation where a step somehow has a negative cost, you need a different algorithm, obviously. The Bellman-Ford algorithm is an algorithm that can fit this case scenario, and I'll attach a link to that underneath this video. From routing data packets to guiding your next turn, this simple greedy algorithm, which is Dijkstra's, is a cornerstone of modern pathfinding.